Hi, so this is a little introduction to the alpha version of iSkills. This is for VR headsets, and the idea is to give people a chance with strabism and amblyopia to learn to use both eyes again. And this can work because a lot of the problems are neurological. The brain has failed to learn to use both eyes at a critical stage in the development of the vision system. But when presented with the right kinds of challenges, cut down to the bare minimum, there's a chance that the brain can relearn to use both eyes if any physical obstacles are removed. So first of all, we have to figure out a little bit about what's going on. So we see here in this very first iteration, we have calibrations and experiences. The calibrations build on one another. First of all, we start with binocular suppression. That means we're trying to find out, is one eye suppressed? Does the person have amblyopia? Now, when a person has amblyopia, the signals reaching the brain are weaker from the amblyopic eye than from the non-amblyopic eye. And the brain effectively only sees the input from one eye. The reason for this is that the brain doesn't want to be confused by seeing double. If it can't merge those two images into one, which is what happens in the normal case. So, it's possible to overcome this, to get people to start seeing with both eyes again, even if they have amblyopia, by increasing, let's just say, the volume of the signal from the amblyopic eye and reducing it in the good eye, so that the signal strength as it arrives in the brain is similar from both eyes. And we're talking about the electrical impulses here at the back of the eye that are sent and received by the brain. So let's take a look at this. First of all, you put the headset into the VR player, or the VR headset. This is designed to work with cheap VR headsets. And what we see is hexagons on the left, circles on the right. Inside the VR headset, because the left side of the screen is presented to the left eye and the right side of the screen to the right eye, these will appear to be directly over one another. And they're over one another instead of left and right, because at this point we don't know if the person has any eye misalignment. They're less likely to have vertical eye misalignment, and it's likely to be relatively small, which means that when and if the person is able to see both images, they will most likely be top and bottom. If we tried to present them in vertical columns, left and right, they might not even be aware that suddenly one side is showing, because it will be overlapping by some amount on the other side. So that's the reason. So in the VR headset, they can just move their head up or move their head down. And that changes the relative intensity of the images. You're just moving your head up and down. So let's say your left eye is suppressed and your right eye isn't. This is what you'd probably be seeing. You'll be seeing the image in the right eye and nothing in the left eye. If you move your head up, if we can do anything here for this particular person, perhaps let's say here, the person is able to see with the left eye a dim image, and with the right eye also a dim image coming in, as in they're balanced. It's overcome that suppression, that threshold. So with a Bluetooth controller, we'll now click on OK, and now what we'll find is in our settings we now have a binocular suppression ratio of minus 0.72, so that's the ratio between the eyes, and we'll now use that in all following tests.